Hello everybody and welcome to Handmade Hero, the show where we code a complete game live on stream. We may take a brief digression here at the opening of Handmade Hero because we wanted to see, last night I was playing Children of Morta, which came out recently. And one of the things that I notice a lot of times when I play at least Unity games that are pixel art games, they have this sort of problem where the shaders are not written properly. I don't know if this is just a problem with Unity or what the problem is exactly, like why they don't have proper shaders. But basically what ends up happening is you don't actually get to see the pixel art in all of its beautiful glory because they haven't done subpixel sampling of the pixel art itself. So it's really kind of sad because it's literally just a little bit of change to a shader and you get way better results than you would have gotten if you if you do it the way that it happens in Unity. So I was curious to take a look at that today. So I thought what we might do today is just play with nSight a little to see. I don't know if we can, but I figured it might just be fun as something we don't normally do on Handmade Hero to do a little reverse engineering potentially to see if there's any way we could fix the shaders in Children of Morta without actually having access to the source code to make it so that it was actually rendering the pixel art properly. Kind of try and fix Unity's code for them. I don't know, maybe I should ask them to pay me, but what I'd like to do is just see if that's at all possible. So the first thing I'm going to do here is just see if it's possible to attach nSight to a running Unity game and get anything meaningful out of it. Now, I'm going to kind of explain how this works, and if nothing else, if this part works, we'll at least get to show how to deconstruct a game's rendering pipeline, which I think is interesting anyway, because it's a good thing for people to know how to do in general, because you can learn things about graphics programming and how people accomplish certain things. A game like Children of Morta probably isn't one you'd normally do because it's not really a graphics-y game, but you know, if you have something like the latest Unreal Engine game on your machine and you're playing it and you're like, wow, how did they do those graphic effects? Well, reverse engineering the graphics is something that is a very easy way to go look at how they're accomplishing the rendering passes that they do to create those effects that you see. So what I'm going to do is I'm just going to launch the game as I normally would. So I'm going to go ahead and see if I can just launch it here directly. It looks like I can't, so I may have to just run it through Steam. Yeah. So I'm going to go ahead and run Steam here. Or try to. There it is. So my Steam is now running. I'm going to click on Children of Morta and have it run. And then what I'm going to do is once it's running, I'm going to try to get to a point where I can see sort of the issues with the pixel art happening, which may be hard for you to see because the video compressor on Twitch compresses it into a real mush. But hopefully I can get to a point where, you know, at least I can see it. Hopefully you can see it too. And then we're going to go ahead and take a look. Alright, I don't know if we can actually skip this. I hope so. Alright. I don't know if we can skip it, so I'm going to go ahead here, and while that's playing in the background, I'm going to go ahead and open up nSight. Alright.
Margaret awoke, startled, a cold sweat clinging to her. She gathered her thoughts.
I guess this is a fine location for it. I really don't want to watch this cutscene, but I can't find any way to... Oh, there it is.
Through the quiet
there we go.
room,
Just got to hold escape to skip, apparently. That's what I wanted. So you can see, I don't know if you can see it, but there's all kinds of artifacting just as I'm like zooming in. It's super artifacty. And in fact, I want to say I think we might actually be seeing it just in the... I can just move the mouse and see it. But I think probably if they're doing this procedurally, meaning they're moving like this, a actual... which we'll be able to see when we deconstruct the frame. When it's moving like this, we'll be able to see the pixel problems in here. I can see them right now. Hopefully you can too. Where it's just like stuttering across pixels. And you can also see the sort of shimmering that happens as I move around the mouse because all of the background is also being sampled improperly as well. Again, don't know if I'll be able to help with any of this because I only have a limited ability to do so doing reverse engineering. But what I'm going to do is just go into nSight, and anyone can download nSight. You can literally, we've done it on Handmade Hero. We downloaded it live, I think. So if you don't know how to do that, you can look for my stream on it. But really all you have to do is just go to Nvidia's website. They actually got rid of the having to have an account, which is awesome. So you can go to Nvidia's website. You can go to the nSight page. Just type in Nvidia nSight on like Google or something. Download it. As long as you have your drivers up to date, it should just work. You should be able to just launch it like I have it here. And then we're going to create a new project and just hit OK. And then we're going to try... Now, you look at here, again, I'll try to explain this in a sort of a beginner-friendly way because I don't know who might watch this stream about reverse engineering at some point. What we're doing here is nSight is essentially a utility that allows us to capture what a application is sending to the graphics card, right? Because it has to send it through known APIs, D3D11, 12, OpenGL, Vulkan, right? You can see them right here. These are the ones that might be running on Windows. What this app allows us to do is insert ourselves into that pipeline and capture the commands that were sent via OpenGL or D3D or whatever it was, right? Now, there's two ways we can do it. One is we can launch the executable ourselves, right? I can put Children of Morta in here as an executable and launch it via nSight. nSight will then run the exe and capture it that way. I'm not going to do that this time. The reason I'm not going to do that is because Children of Morta is a Steam application the way that I have it installed now. I bought it on Steam, so it runs through Steam. What that means is, although the Children of Morta executable exists on the actual hard drive, you can go see it. It's in the Steam apps directory under, C program file Steam Steam apps or something like that. I don't remember exactly the path. Well, you know what? I'll show you the path. This is meant to be a beginner-friendly stream here, so I'll show you what I'm talking about. If you actually open up okay, so it's in x86. If you open up your program files x86 directory, you can see there's a Steam directory. Inside there's a Steam apps directory. Inside there's a common directory, and here's all your games, right? So if I go into a particular game, in this case Children of Morta, you can see that the Unity distribution is just sitting there. So it's not magic. I can run it directly from here, right? But what typically happens at the startup of a standard Steam application, if I remember correctly, it's been a while, is that the first thing they do is check to see if Steam is running. And if Steam is running, they actually thunk back to Steam, tell Steam to run them through Steam, so they get the overlay, the Steam overlay and the communication with friends lists and all that stuff, and then they exit. So the Children of Morta exe actually just becomes a Steam launcher that launches Steam and tells Steam to run Children of Morta. Okay? I know that's a little confusing, but you have to remember players, when they run a particular game and they want to have that Steam experience, right? They want to have the voice chat, and they want to have the Steam friends list, and they want to have their achievements and all this other stuff that comes with Steam. And so typically when there's a Steam game, it installs an executable. At the front of the executable, it says, is Steam running, or is installed in this machine? If it is, then just send a message to Steam to say run Children of Morta, and then just exit, right? And that ensures that you're always running a Steam game through Steam, because that's presumably what the player wanted. Otherwise, they wouldn't have bought it on Steam, right? So just keep that in mind. So the reason that I'm not going to do the launch here, and we might try it later, but the reason I'm not starting with that is because I'm concerned that that won't do anything. Basically what will happen is it will launch the executable, and the executable will just send a message to Steam and then exit. And then we'll have Children of Morta running, but we won't be able to capture it because it's actually a different instance of that executable. So what I'm going to do instead is use the second way that you can attach nSight to a process, and that is to... oh, never mind. I guess I can't do that. Only because the launch from instant can be attached. Uh-oh. Well, I guess we could try. I was going to say, hopefully I can attach it here, but it looks like you can't actually do that with nSight, or you can't do it anymore. So I can't actually do it that way. I'm going to have to find a way to actually launch Children of Morta directly without Steam being involved. We'll try it. It's pretty dicey. What I could do is launch Steam through nSight. That might work. But I don't actually know if it will. So this is going to be harder than I thought it was going to be, but we'll give it a shot. Let's go out here and exit Steam, and I'm going to see what I might be able to do in that regard, just to see what we can come up with. So the first thing I'm going to do is I showed you that launch directory here. I want to see if I'm right about it thunking to Steam. It may or may not do that. I'm not sure. But I'm going to see first what actually happens. So if I double click on the executable, let's see what goes on here. Does it try to thunk through Steam or doesn't it? And I'm not sure. It looks like it didn't. So I'm hoping that that just means that's not something that this app will actually do. And if that's the case, we're in luck. We don't have to worry about the thing that I was talking about because they didn't do it, right? So I'm just go ahead and try launching this executable directly. So what I'm doing is pasting in the full path to that executable here. And I'm also going to launch it from its directory just in case it needs that, because I don't know what it's expecting, but I'm assuming that it expects to be launched in the directory of its executable. We're not going to pass any command line arguments or set any environment variables, because as far as we know, it should just work, hopefully. This creates a project for us, right? I'm hoping I can just save that project and save these so that then if we crash or something, we'll be able to load it back up. And then I'm just going to say launch. And we're just crossing our fingers, right? So it looks like it's using something called tiled resources, which it says it doesn't necessarily support, which is, and it also says unsupported OS detected. So we're I guess we're in a little bit of a rough spot here. So it looks like nSight's very unhappy with this capture. We may have to try render doc. Again, all we're trying to do here is just get a general capture of this thing, which is looking pretty difficult to do. But we'll see. Oops. I didn't mean to do what I just did. So I'm just going to try and skip these cutscenes here. I don't know if I can or can't. Looks like I can't. I don't know why sometimes holding escape skips the cutscene and sometimes it doesn't. But I guess I don't care. The question is, does this think it's running? It doesn't.
Margaret awoke, startled.
So it's going to allow me to attach
sweat
because I did
clinging
launch it
to
from
her.
here. So I'm going to go ahead and try to attach a frame debugger to it. But I'm going to wait
gathered
till we
her
get to the
thoughts.
point where I actually want to try a capture. So we'll see. But again, not looking particularly happy. All right, so if I can get a frame capture anywhere in here, I'm going to be happy. So I'm just going to go ahead and try and attach it and see. We'll see what we can do. So it looks like it's sort of attached. Looks like it. Don't know. But since we've got an attachment, I'm just going to try it. So I'm using Alt-Tab right now to switch back and forth. Normally, if you have two monitors, you would put nSight on one monitor and you put the game on the other. But that's, all kind of a separate issue. So here is our frame that we're going to try and capture. what I'm going to go do is go into Children of Morta, hit Frame Debugger, capture for live analysis, and cross my fingers that it's able to capture any of this stuff, even though it keeps complaining about all sorts of API errors. I don't really know exactly what that's about, but we'll see. So now you can kind of see we've got a frame capture. Who knows if it's correct or not? But as we go through here, what we can see is that it did actually capture a D3D11 stream. So the first thing we know about this game is it doesn't use D3D12, it uses D3D11. That's just something we now know. That makes sense because this is a game that probably wouldn't benefit much from D3D12, and D3D12 only runs on a subset of systems. This here is, if you look at the different panels here, again, trying to make this somewhat beginner-friendly. We've done this on Handmade Hero, so I don't want to belabor the point too much, but what you can see in this layout is we now have the ability to kind of look at what's happening during a frame. Now, this window here, the scrubber view, tells me what's happening in the frame over time. And what you can see is, and when I say time, I mean time of a single frame's API state, right? So if you imagine that this is essentially all of the calls to the API that have happened, and all of these lines here are ones that actually issued like a rendering call. Because remember, graphics APIs, they typically set a bunch of state and then do an issue of a call. So you do like set the viewport, set some texturing up, and then like sync a bunch of triangles. That sync a bunch of triangles actually now does work. Those previous commands didn't do any work. They were just setting state up in order to do the work. So all of these empty areas in here are things that were setting up stuff, and all of these notches are things that actually did work. What this scrubber view lets me do is jump anywhere that there was work and see what got rendered. So here you can see it rendered some kind of a circular region, and you can see in here the color buffer. I'm not sure what that actually was. If we jump to the end of the frame, I don't know if there's maybe some kind of, I don't know what's actually there. If I look maybe right before, yeah, I don't know if that's some kind of fogging bloom or something. It's hard to say. But what you can see is it's pretty nice as I jump around here. You can see, if I actually expand this out, so you can, one of the unfortunate things is it doesn't subsample these marks well. So there's actually marks you can't see. If you zoomed in more, you would see them. I don't know if we kind of zoom in like this, right? Here you can sort of see where those actual marks all are. So each of these blue ones is something that actually synced some render, something that could render. So what it looks like here, it looks like they're rendering some kind of like fog in there, right? You can kind of see it happening. If I pull back out and maybe get this window a little bit bigger here, so you can see it. You can sort of see as it comes through all of those render commands. It looks like maybe that's fog. It could also be like texturing ground passes. I'm not sure. Hard to say. You can see here we're tiling the ground with stuff there, I guess. Not sure where we lay down the actual ground splats. Okay, so those are ground splats. So you can kind of see what's happening, I guess. This right here laid down a base coat on the ground, it looks like. And now we're splatting down ground textures. If I go ahead and take a look at this guy, I don't know if I can zoom this in at all. Looks like I can't for whatever reason. That's too bad. What can I do here? Display wireframe, flip image. I can't really zoom this in much, so I'm going to maybe try and just make it bigger here so you can see it. You can see that it sort of rendered a base repeating pattern onto the ground that's very dim. I'm not sure what that was meant to do. It might have something to do with other types of rendering that happen. But you can see these ground splats. There's a ground splat. There's a ground splat. So what the game is doing right here is it's laying down those initial ground patterns in a way that blends them together. So it's just doing a lot of overdraw there to splat the ground together into something. So it's not fog. It's just placing ground, right? Placing ground tiles. You can see it doing that. We're now rendering, that right there is the player marker. So for whatever reason, the player marker got rendered at this time. That may just be happenstance. It's hard to know why, because the texture in the terrain hasn't been. So here's probably why it got rendered at that time, if that makes sense. It looks like they've broken this up into two passes, rendering a flat ground plane, then putting stuff on the ground plane, then putting stuff over it, right? So it probably got rendered because it's just part of the flat ground plane. That marker is sort of supposed to be sitting where the player's sitting, right? And so now we're putting like trees and other sprites on there that we need to kind of stack up for the player to experience, right? And you can kind of see a little bit of bugginess there. That probably isn't, I mean, it might be, but it probably isn't in the actual game. That's probably because of some of the API capture bugs we were seeing before that was warning us about. That's probably just, or, you know, it might just be an artifact of how it's redrawing, because you can see it's not there when we go in here. So I don't know what's happening there exactly, but those are probably not things to be concerned about. It's probably just artifacting from the capture. Here you can see drawing the dude. You can see that we're composing the world upside down, by the way. The dude is standing upside down from where they are, and those trees are upside down. But anyway, if we now look in here, let's take a look at one of these trees specifically, because this is an example of the kind of shader that we wanted to look at. Where is that large? There it is. So this tree here, if I look at it in more detail, I don't know if I can zoom in on this. Is there any way to zoom in on the... I don't think I can zoom in on this view, unfortunately. I can zoom in on the texture, like here, right? So we can zoom in on this thing. And one of the nice things about it, too, is, you know, they've made the checkboxes that we actually want. You can see where they've got flip image, because they know a lot of times things get rendered upside down. So we can sort of see that this was one of the things that was flickery when it moved. And it's hard to say to what extent they're shifting this, but you can see that it is, for whatever reason, more than one triangle pair for that. It's not just a quad. I'm not sure. I'm really just not sure exactly why. I don't quite know what's happening there, why it looks like that. It may have to do with something, the way Unity works. I don't really know. But anyway, I'm going to stop there. And I'm going to go look at what shader was used to draw this to see if I can gain any insight into whether we will be able to improve the sampling quality of the pixel art here. So if I go into Pixel Shader and I take a look at what's going on here, I can see all of the stuff that's happening in the pixel shading pipeline, right? If we step through this list, I guess I should, again, just to be clear for folks who have never used a utility like this before, this API inspector view is basically, once I've dialed in up top here, once I've dialed in the particular render call that I want to inspect, and by the way, we didn't mention it, but this right here updates to match this. This is just a listing of what the APIs actually were. So on this issuance, this was the command. This was the direct 3D11 command that was being called, draw indexed. It's drawing 12 indices. It's just this tree, right? It's a very small batch render issue. And you can see anything else you want to see about the particular call. We don't care about that right now. What we care about is all the state that was set for the call. Specifically up here, you can see it's setting up the shaders and the samplers. By the way, crazy how much overhead there is here. I would have expected Unity to be more optimized than this. This is kind of ridiculously bad. Far, far worse than Handmade Hero, which is something that we did on a stream by ourselves. That is not meant to be a reusable engine. That, I just don't understand how it's looking that bad, but it is. There's a map, unmap before every single one of these. This is to update these constant buffer. Like, there's no batching at all from what I can see. It literally draws a little chunk at a time. Really, really bad. Not sure whose fault that is, but maybe that's why Unity games are so slow all the time. Anyway, moving back over here, taking a look at this issuance here. This window, the API inspector view, is basically a breakout of the information for the thing that we're stepped to. So remember, we're stepped here at 522. Let me get back there. We're here on this call. this API inspector view is a breakout view of everything that happened on that call. Again, it allows us to see what's going on. If we take a look at this list here, these are the stages of rendering as they occur logically, not necessarily on the chip, but logically. So here is the input assembler. What that's saying is, what are all the inputs to this command that are relevant? You can see here, this tells us how the vertices were coming in. There's a position, a normal, a color, 4 sets of texture coordinates, and a tangent frame. Why on earth you would need all that for a single batch of something that needs none of those things? It's probably only this one, and this one, actually. Who knows? Again, just large S from Unity. Who knows? Probably looking at the fact that these are all at offset 0, it looks like maybe they just forgot to turn them off, or maybe there's no cost to leaving them on because the shader doesn't fetch them. I'm not sure. So that's fine. But it's using probably at least these two. So you know what? I take it back. There might not be any large S here. It looks like their offsets are properly set to 0 for all these, so they're enabled in some way, but not actually being read, I would suspect, so it's not actually wasteful. It looks like it's only using position color text chord, which is what it should have. So no bad there. All right. Here are the vertex buffers that are coming in. It looks like there's some kind of global sampling buffer coming in here. This is a secondary vertex buffer. This looks like the primary vertex buffer we're actually sampling from. This one has a stride of 0, and so it looks like this is just constants that are coming in here as a vertex buffer instead of as a constant buffer. Same thing with the index buffer. So these are the 2 buffers we're actually looking at here. We don't care about those because we don't need to adjust what's being drawn. We just need to adjust how it's being drawn. So those really won't concern us. So I'm just walking you through this, but we don't care about the input assembly stage pretty much at all. At the vertex shading stage, probably same thing. I won't really have to modify the vertex shader, but if you did have to look at what was going on in the vertex shader, this is the place to do it. Here, I believe, is how you would actually look at those shaders. You can see in here you've got the disassembly of the shader and the statistics and so on, right? And so, you know, that's what's happening to the vertex shader. If we pop out the disassembly, you can see here what's going on in the actual shader. What I don't know is if there's any way... so this is pretty much what's going to stop us, right? So that answers our question, whether we can fix what's going on in the shader. If I can't edit the Hlsl bytecode, or produce source and then change it, then there's really not much I can do, right? Because what I want to be able to do is edit this shader, not this one specifically. I want to be able to edit that. I wanted to be able to edit that pixel shader. So let's take a look. Let me close this. Actually, I don't really know how to close that properly. There we go. So let me finish walking through this, and then we'll see if there's any way we can coax this thing into a mode where we actually could somehow use it. So we look here. You've got a few more things. These are stages that we're not using, so these are not enabled in the game right now. So you can see you've got like the geometry shader, domain shader. These are not being used, so that's why they're grayed out. We then get to the rasterization stage. The rasterization stage is just a thing that basically tells you how it determines which pixels were filled. There isn't a shader that operates at this stage on an Nvidia part. And so really all you've got are settings, and these are those settings. There are things like whether it was solid or wireframe fill or things like that. Whether or not there was culling turned on for backface culling, things like that. You can see it's not turned on. That sort of stuff. Again, don't need to change any of that. Here's the money. This is what we actually wanted to edit. Doesn't look like we'll be able to, because if I go to the disassembly here, I'm assuming it'll say the same thing, which is that I can't edit it. And what I would like to be able to do is edit it and change the way that it's actually doing its sampling to get me better results. Now, I can't do that, so we're going to have to try and figure out a way that we could actually change that shader. So looking in here at what's going on, you can see the pixel shading happening. This is all of the information that was going into the pixel shader. Again, we don't really care because everything that's going in is what we want, the texture and so on. But if you were trying to figure out, like, you know, you can see actually also in here information about what was happening with the sampling. You can see that it's just doing point sampling on everything, which is why you're getting that crispiness instead of like bilinear, which, you know, makes perfect sense, obviously. So anyway, the bummer is we can't edit the shader, so we're going to have to try and figure out some way to coax it into allowing us to edit that shader. I don't know if maybe RenderDoc would let us do it or not, but there is another way we might be able to do it. I don't think there's any way to tell Unity to run in OpenGL mode, but maybe there is. And if there was, that might help us because OpenGL doesn't really allow you, except with extensions, to submit compiled bytecode. So I'm wondering if there is some way to force OpenGL on a Unity executable. I'm not sure, but that's where we're at. Now, if we actually were to look at this disassembly here, I think if we could have edited it, we would actually have... Is there any way to get this... There it is. It's like I wanted this to be a pop-out window. So if we actually looked at this, you can see the disassembly of the shader. You can see here that there's basically an if clause that stops the actual shading from occurring here and just dumps a standard like value out to the stream and skips the shading here. We have another one of those happening here, right? And so if we take a look at what's going on, you can see that there's samples being taken from S1 and S0 and S2. And so if I look at my actual... I don't want this thing to dock. There we go. If I look at what's actually coming in on those slots, that should give me some idea of who I actually would need to update here. So let's take a look at those three textures in order. So here is the first texture. Okay, so this just looks like the map, honestly. Yeah, so for some reason the map is active in slot 0. If we look at what texture might be sampled in slot 0, just to get some, go ahead and make this a little bit more visible. If we were to look at which texture operations were targeting that, if we look here, sampler 0, I believe there's nothing special about any of these samplers. And if we look at the samplers here are the textures that went into those slots, which I believe are just bound per sampler. So I believe like this would be sampler 0, this would be sampler 1, and this would be sampler 2, I believe. So if we look at where those are actually getting sampled, if we pull down to places that sample from slot 0, which is the map, you can see that there's really, it's kind of out in here. Same with this other texture that looks like some kind of a bloom effect. Maybe that's some kind of lighting or, you know, some kind of special effect that's going on there that maybe got rendered for lighting purposes. Those two are getting sampled in the top branch, I'm sorry, the bottom branch. And what you'll notice is the actual sprite itself is not being sampled here. So this looks like something we wouldn't really care about because it's not actually sampling a sprite. This looks like it is the thing that's sampling the sprite. And if we take a look at that texture here, you can see, I guess, I almost want to say the animation is baked in. Is there any way to flip this guy around? Guess I could do it in the shader. I was hoping there was a nice little I was hoping there was a way to just do a one-click flip like we were doing in the other one there, but it looks like there isn't. But anyway, if I look at these, so a couple things about them. Really kind of confused right now. As I look at this, I'm not sure what to make of it. for a number of reasons. So I'll just start and I'll go through them kind of all together here. So the first thing is, it looks like that waving was actually just done in an external application. So I can't actually fix this stuff. It looks like the bad pixel sampling is built in to the actual image, which is unfortunate, right? But maybe that's okay because, hey, the panning and zooming part I could fix, right? But looking at it, that's definitely a problem. The other thing I would say is, it looks like this game couldn't have Mipmapping turned on without it a bunch of work as well. So that was another big source of the sparkles. The reason is because it's not using Premultiplied alpha. So the reason I can tell that it's not using Premultiplied alpha is you can see that the colors are smeared, right? They're smeared out. And what that means is that if I look at how the alpha channel looks, I'm not sure how to get the alpha channel. Probably. Oh. It does have flip upside down. Just didn't know where I was looking. So there's our upright actual plant. So if I look at the alpha channel, with the alpha channel on, you can see that if this was using a premultiplied texture, premultiplied alpha texture, then when I clicked this, all of this would be black. And the reason it would be black is because if the alpha is 0 somewhere, then when you do premultiplied alpha, it means that your RGB channels are multiplied by the alpha channel. So everywhere that there's no alpha, there would be black in the color channels. That's not what's happening, so I know that this is not a premultiplied alpha texture, which means it cannot be mip-mapped properly without an additional shader. So I wouldn't really be able to fix that part either without doing multiple samples from the texture. I wouldn't be able to use the mip-mapping hardware, which is kind of a bummer. But that's not the end of the world. I could just add those extra samples, get slower, but get correct mip-mapping on my plants here. So yeah, let's take a look though. We know that that is the thing that's actually being sampled as the sprite. We go in here and we look at all the samples taken, and you know, there's a heck of a lot of information in this side of the sampler. I'm not sure what it all does, and it might be a bit laborious to go through the whole thing, but you know, we're gonna have to try and at least make some sense of it if we want to understand how we would necessarily modify it. So, you know, coming in here, we've got some registers that are, you know, getting used here. I assume those registers are just scratch registers, probably. You can see them being used here. And then we've got like our Vertex inputs. You can see like Vertex input happening here. And then we've got like a constant buffer happening here and so on. So if you take a look at what's happening with the sampling in this part of things, I'm guessing, just looking at what's going on here, and this is taxing my... I'm not a reverse engineer, so my brain is not like sort of set up to quickly guess correctly what's going on in a lot of cases. But I'm guessing what we're sort of seeing here in terms of taking these samples, the fact that we're taking multiple samples is a little confusing, because I'm not sure why we would be doing that. In order to take multiple samples, you would think we would have to be doing some filtering, but I'm not seeing any filtering, right? If I jump back to the actual Children of Morta, well, I guess I can't necessarily. Maybe if I do resume, I don't know if that will destroy my frame, though. I don't know to what extent exporting this as a C++ capture would actually work. It would be interesting to see if that did work. That would allow us to potentially edit the shaders as well. So maybe we could do something like that. I'm not sure. Anyway, the point is, I wanted to kind of show you the sort of the crispiness that I was seeing there. But the fact that I'm seeing all that flickering and crispiness, I don't understand what all of these samples could be, because if you're taking multiple samples, you should be getting at least some filtering. If you're only getting completely unfiltered results, why are we taking so many samples of that texture? And I really don't know. So that's a real puzzler. That's a real puzzler. Let's try to take a look here. So the first thing we're doing is we're taking an input from V2, right? And you can look here and you can see that these are the inputs from the Vertex shader, right? Here's our textures, right? I'm sorry, here's our texture coordinates. Yeah, here's our texture coordinates. I don't normally use D3D, so it's hard for me sometimes to back map. Here's our samplers, S0, S1, S2. It's S1 that we care about, as far as I know. Unless, maybe I'm reading this wrong, and S1 doesn't map to this texture. I mean, it could be, but I'm not sure how else to interpret this, because you have the samplers in slot 0, 1, 2. I believe slot 0, 1, 2 here corresponds to the samplers, which means that anywhere you're using sampler 1, you are sampling from this texture, as far as I know. Unless I'm misreading the D3D there, but I think that's how this would look. And so I believe that this is the only thing we actually care about, is this T1, S1. I believe. Although, actually, the T1... So looking at this, we're doing sample... Oh, no. I'm reading the D3D wrong. So that's, yeah, lesson learned. I believe that actually it's pairing, the samplers are being paired dynamically. Mystery solved. Okay. Whew. You learn something new every day. So if we look in here, what we can see is the D3D disassembly, the samplers are the S's, the textures are the T's. That's how this disassembly is being looked at. That's just my bad. Again, I don't normally use D3D, so I have no idea how to read these readouts. I kind of know how the graphics cards work, but I don't know how to necessarily map that to it. So that was just a piece of the puzzle here. All right. So these slots and these slots are being paired using this nomenclature. That means actually what we're looking for is people who sample T1. That makes things so much better, because what that means is that anywhere we were seeing T0 here, and you can see T0, 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 T0 in this first branch, that's actually sampling the map. That's sampling from texture 0. It's just using sampler 1, which again is this one. So it's sampler 1 paired with texture 0, just throwing you for a loop there. Big deal, we figured it out. So it is the simpler case that we're looking at, and that makes so much more sense, because like I said, I could not figure out why we would be sampling 4 times. Now, I still don't know why we're sampling the map 4 times, but that's kind of a separate issue. Maybe this isn't the map. Maybe this is some kind of an assembly thing that they... who knows what that's for. Maybe it's a depth thing. I really don't know. Doesn't matter because we don't care. This is the branch we actually care about. It only does sample once, which is exactly what I was expecting based on the results I saw. So you can see why I was nervous. I'm like, I don't know what this would really need to do for the output I was seeing. Doesn't make a lot of sense. Now it makes a lot more sense. Here we can see our texture samples and we can interpret them properly. T1 and T2 are these 2 textures right here. We don't care so much about the T2. That looks like a lighting overlay, some kind of a light contribution sample that we don't really care about. So this T2 sample we can effectively ignore. R2 we don't care about. This is the sample we care about, sample R1, and this multiply here. Basically what that's doing, that multiply, is probably applying a Vertex color channel. So it's probably saying, hey, I might want to change the color of this thing. You know, maybe it's if I'm flashing it or whatever. Oh, we got a puss. We got a puss. Hello, puss. Hello. How's it going? What's up today? We saw the prime puss on a little bit earlier on the stream, and the puss has rejoined us. I think the puss wants to look out the window, so I'm going to put her in her little seat. There you go, puss. There you go, puss. Do you want to look out? Oh, there's so much good nature today. So much good nature out there. Isn't that true? Yeah, that's good, Puss. All right, so I'm hoping the Puss will maybe just make herself comfortable and enjoy some of the outdoor sights. I don't know. She might want attention, in which case we might be in trouble. All right, so again, I think this is just taking and doing some colorization of the sample. So this is sampling the sprite. This is coloring the sprite using an input. And then a bunch of stuff here, you know, looking at this, we got a DP3 on here. That's probably used for some kind of, well, no, it's not. Because it's hard-coded, so it's probably not actually doing that. So we got two DP3s. This might be a lighting one, might not be. Hard to say. I don't know exactly what they're doing here. They're trying to pick out some channels of the color there, so I don't know. So this stuff we don't necessarily care about. This is like the post-filtering, doing some presumably working with how these two samples want to get combined or something like this. So all we would really need to edit is right here. You can see that T1XYZW, right? And you can see on how we're taking the sample, this one sample coming from texture 1, because we're only taking one sample from it and bilinear and mipmapping are both turned off, it means we will get no filtering, right? So all we would really need to do is expand this sample, this line right here, to first figure out some more places to take a sample from, and then we would sample it multiple times. Now, normally you can be a lot cheaper than that. Normally, if you turn mipmapping on, which we can't do because we're not in control of the Unity pipeline, because we don't have the source code, you can just take one sample. And what you do is you precondition your UV coordinates and then take a single bilinear sample, and that gives you perfect pixel art upscaling. But we can't do that, but we can approximate it by just forcing the G-force to do a crap ton of extra texture samples. Now, fortunately, they're all from exactly the same place in the texture, so they're very, very fast texture samples. But again, you still wouldn't want to do this. You'd want to just use the bilinear hardware. And so all I would really need to do is update this sample line. And what I would do is I would take the sampling from the texture, and I would take the UV coordinates, and I would just add the differential UV offset for sampling inside the pixel I'm in, right? And let me draw on the whiteboard what I would be doing. And then we can try to figure out a way to coax coax Unity or somebody to let us actually edit this shader somehow. And I don't know how best to do that. If this were an OpenGL app, or if they had shipped Hlsl source somehow, we would probably just be able to do that. I don't think they did. I think those are like packed into the Unity files. If you go out here, you know, the best case scenario is they're just sitting in some directory here. But I'm pretty sure they're not. I'm pretty sure they're like, you know, stuffed into this stuff somewhere. You know, who knows where. But I'm pretty sure they're just kind of, you know, they're probably in here somewhere. And I don't know to what extent we would ever have access to them. I don't think, for example, there's just an Hlsl file sitting around, because they probably just compile them. Unity probably just compiles them and shoves them in to the executable. That's my assumption. I don't use Unity, so I don't know. Anyway, let me pop over to the Blackboard for a second and just kind of give you a sense. I accidentally hit the zoom there. I don't know. I don't want to zoom in too much. See where we were at. Probably right about there. Yeah. Let me go ahead and show you. So if we want to sample pixel art properly, like I said, there's two ways to do it. I'll cover the brute force way first, because that's the only one we would really, I think, be able to inject into Children of Morta, best case scenario. And then we can also just briefly mention what you would do for the more efficient version if you are writing your own game. So what happens with pixel art upsampling? Well, what happens is normally we, you know, when we talk about a texture, we pretend that the texture is basically a capture of something that had like infinite resolution, right? We pretend that we were taking like a photograph or something, and then we're trying to reconstruct what that photograph would look like if it was stamped onto something in the world. Like, for example, if we took a photograph of a brick wall and then stamped it on a flat polygon in our game, we want it to look like a brick wall. What that means is when we reconstruct it, we assume that the points that we have, the texels that we have in our texture, are actually just sample points of something that was actually much more resolute to begin with. That picture of the brick wall might have only been 1024 by 1024 or something, but in the real world, atoms are much, much smaller than that. We should have had a 80 billion by 80 billion picture of the brick wall. And so when we go to sample it, we just assume that, well, what's in between the pixels is just maybe some smooth blend between the two, because we don't actually have the extra detail. But we know there was extra detail. Pixel art is not that way. Pixel art is sort of like saying there is no extra detail. The point is you can see the pixels. They're big blocks. There isn't anything in between them. They are not samples of some more high resolution signal underneath. They are the whole signal. What that means is that if you take some piece of pixel art that I make, let's say I make something that looks like this, right? When I go to draw that on the screen, if my screen is like way more resolute, so, you know, maybe I'm drawing it on a screen that's way more resolute, as the case of pixel art, I'm going to map this thing, and let's say onto the screen it maps quite large. Maybe a little too large. Right? So this maps to this square here, right? I'll try to draw that a little bit better so you can see it. Here's my pixel art. And so I'm going to change my terminology a little bit. I'm going to call it texel art temporarily to differentiate between the pixels on the screen and the texels in our texture, right? So the pixel artist is really a texel artist nowadays. They're not drawing pixels because pixels are things on the screen. They're drawing texels, which are things in the texture map, and those texels are getting put on the screen. And ideally what we want is we want them to look like little blocks. This is different than pretty much anything else we do in graphics. We never want our textures to look like little blocks. That's considered ugly and bad most of the time. In pixel art games, let's call them texel art games, we actually want them to look like blocks. So what that means is we can't just turn on naive bilinear filtering. Why? Because let's see what that will do. Let's suppose we turned on naive bilinear filtering and we looked what happened to this grid of pixels here on the screen. Well, this pixel here would have gotten basically just this color because it's going to hit the border and clamp out here. This pixel here would start to blend. It would blend between this pixel and this pixel here because it is some distance towards this side, right? Well, actually, that's not true. I'd have to probably cross the center line first. So let's talk about this pixel and this pixel. As I got to this pixel, I would start to blend between this and this, right? So instead of getting solid, let's say this is red and this is black, instead of getting a solid red color, which is what I probably want for my texel art, right? Instead of getting a solid red color, I get a blend between red and black. And then here I get even more black until finally when I'm here I get complete black, right? That is not what I wanted at all. This, because this is a texel art game, this should have been full red, right? Because we're talking about blowing this entire texel up so that it looks like a solid rectangle, right? So anything, all of these pixels here should have been solid red, even though bilinear filtering says that it should be a blend between here and here. It probably would be about, let's say, 15% black, 85% red. That is what this would have been, right? And that's precisely why turning on bilinear filtering looks so bad with texel art, with pixel art, right, games, is because you get this smearing effect. Because it's pretending that there was a signal in between, you know, that we just weren't sampling, where it wasn't just a hard step from red to black. It wasn't this, right? Red there, black here. This is texel art, right? This is bilinear filtering. So we want that hard step to actually appear, right? So what most games do, and what Children of Morta does, is they just turn it off, right? So they take bilinear filtering and they just turn it off. They turn off mipmapping as well, but that's a separate thing we can talk about in a second. Turning off bilinear means now there's no filtering whatsoever, right? So what happens in this case once you turn off bilinear filtering? Well, if you turn off bilinear filtering, then what happens is it just picks the nearest neighbor. It means this will probably be red because it looks like the center is maybe on the red side, right? And this will definitely be black. Problem solved, right? Problem is not solved, not by a long shot. Why isn't the problem solved? Well, the problem is these pixels along the edge. Turning off bilinear does make this get the correct result, which is solid red. It does not make this get the correct result. Why? Because there is now no subpixel sampling. Now you could just turn on some kind of oversampling on your whole screen and solve the problem that way, but we can do much better. Let's take a look at what's going on. All right, so here's my pixel grid. I should add to Milton, because it's open source, I believe. I should add something to Milton that allows me to just drop down a rectangular grid. Anyone who wants to do something cool, add a tool to Milton that allows you to just drag a rectangle grid, right? It would be so useful. Like rectangle grid and line and stuff, if there were quick hotkeys, you could just hold down a hotkey, draw a thing, and it draws a grid or something, and then goes back to regular pen mode. So good, right? So good. Anyway, so here's what's going to happen. I've got this pixel texel art, right? And the problem that we have is it's not going to stay in one place. If it was, it would probably be okay. But what's going to happen is the camera and the objects are moving very smoothly through the world. They're moving at very high resolution, higher than the pixel grid through the world. And so what happens is they end up in places that are at subpixel locations on the grid. So, for example, let's take a look at what happens right here. There. And then I'm going to draw another one that's what happens when it's perfectly aligned. So I'm splitting this to two places. You'll have to apologize. I have to apologize for my terrible pixel grid, right? Turn off bilinear sampling and then look at what happens when I'm exactly aligned to the pixel, right? And I get exactly my texel art back. This is what, you wanted, and it happened. But shift it a half pixel over, and all of a sudden, we're in a really, really bad state. This was exactly a half pixel over, then I'm probably going to be outside the pixel center here because of the rounding rule. So what's going to happen is this is going to not have anything, right? This, if you look at which ones we're picking up here. So I look at what this actually looks like, right? And it looks like something like this. As I overlay it, right? So if I were to actually fill this in, this is the part of the thing that's filled in at a half pixel offset, right? And so what happens at the half pixel offset, and exactly at the half pixel offset, right, is that I jump from having my sample, like this sample right here would probably go this way, and this sample would go this way. I now fill at the half pixel, right? I fill one movement to the right. So as this thing is sliding over separately, at 0.5 offset, right, half a pixel, I jump one, just immediately jump one, right? And at 0.0, I'm on the previous one, right? So at 0.5, I would jump. I would then travel another entire, the next time that would happen would be at 1.5, right? Because at 1, then I'm aligned with the grid again, so I'm still here. And then at 0.5, I jump one to the side, right? Now, if we just turned off bilinear and then we're totally pixel aligned all the time here, but just moving around subpixel, that's what you would see. You would see just shift, and slowly jerk the pixels around, right? You would just see the pixels roll. That's not too objectionable. It's better than what's happening in Children of Morta, because I'll talk about the next step now that makes things look really bad, right? But it's still not great, because it means that I see this for the entire time, right? I see that for the entire time, right up till I hit 0.5, and then it slaps over one. So what I would rather have done is when we're sampling this pixel, I would have rather pretended that I actually had more resolution and say, let's take the blend inside this pixel, right? Let's take the blend and say, let me sample between these two in the way that I would have for bilinear, and I would have gotten a better result here, right? As it slid, I would have seen this pixel get darker and this pixel get brighter, and it would have appeared that the thing would slide slowly across, right? Okay, so hopefully that makes some sense. If I now go to the case of Children of Morta, which is the bad case, what we actually have is something much worse, and that same sort of jumping at 0.5s becomes a really objectionable artifact. What we actually have is the texel art is much larger, but not by an even factor. So what happens, this we got a zooming camera, right? So there's a continuous change of size relative to the pixel grid on the screen. So if here are my pixels, what I actually end up with is actually end up with this pixel art here that I drew before, mapping to something totally unaligned, right? So now what happens is I get something more like this. Trying to actually count this in some way that I can draw it reasonably. Again, those pixel grids, somebody add that to Milton, please. It would be so good. Okay. So now what you can see is the true problem that we're seeing, why we're seeing all these sort of weird, like it looks like things are kind of made out of jello and they mush together as the camera pans and stuff. The problem comes when a single texel, which we're trying to enlarge, and this is even not as, they're much larger like on Children of Morta. They probably take up several pixels, right? They're probably more like, that big or something, but just for sake of easy illustration here. What ends up happening is a single texel actually maps to multiple pixels. But as this texel slides, what you can see is and you can see this just in the fact that I've got two of them already. These are both the same size, but this one occupies at least like, several texels here. This one's like 4 by 4, right? But this one, because of how the grids happen to align, only maps to 1, right? So instead of being too wide and too tall, which is what my first texel is, this one's only 1 wide and 1 tall, right? As it moves across, it will constantly alternate between those two. As this slides into position here, it will become too wide, and then as it slides out of position here again, it will go back to 1 wide. So as it slides across, all your sprites go 2 wide line, 1 wide line, 2 wide line, 1 line wide, 2 line, 1 line, and you get this like, right? And that's happening at 2 dimensions at once. So you're getting this weird, like, fractured thing as it moves through the world. Again, no reason for this to happen. All we have to do is recognize that we're just trying to do subpixel rendering again with something that is texel art, okay? So all we want to do is when we sample these pixels, we just look, is the entire pixel covered by the texel art of one texel? If it is, don't bilinear blend, because that's the thing that gives us the artifacts that we don't want, right? So for example, let's suppose we took a look at what should happen on this texel here. If we just turned on bilinear filtering, we would get a nasty smear. We would get a smear of like 75% of this thing. We don't want that. What we want is a smear of only the percentage coverage that that texel is on this pixel, which is not what we would get, right? Because remember, if we look at this in 1D, we want this, right? And if these are our pixels, okay, we don't want that line. This right here, this line, that's bilinear filtering, or in this case, just linear filtering because we're looking at it in one dimension, right? And this is what we wanted. Turning off all filtering means that you simply pick either the min value or the max value, right? Either the texel that's filled or the texel next to it, right? Like you know, either this or this. I get one or the other, right? Turning on linear filtering means I sample the line between them. I want neither. What I want is this pixel to pick this value, this pixel to pick this value, so I don't want the line at all, and I don't want any filtering on those. And then when I'm in between, instead of sampling the line at the center point of the pixel, which is what linear filtering would do, I instead want to say how much of the pixel is covered. So I want to know, what is this percentage? What percentage of the pixel is covered by this thing? Make sense? That's what we're trying to do. Now, the easiest way to do that, and the way that's the least efficient, is just spam a ton of samples, right? So let's say we turn off linear filtering, so we're not sampling the line anymore. Just sample a ton of samples and average them together, right? That way I'll get, you know, let's say I go sample 16 samples on this thing. All 16 will come back with this color. Exactly the result I wanted. Most will come back with the color, but some will come with the neighboring color. So, you know, maybe it's, you know, something like 12 and 4. Again, exactly what I want. I average those together. As it slides through, it gets darker as you go by the samples, right? And then finally here, I get all this color. So if I want to do what is basically a, you know, some kind of a grid, let's say I did, this would be way too many samples, but let's say I did 8 by 8, right? That's 64 samples. Way too many samples, oh well. So if I did an 8 by 8 grid of samples in my pixel, so I just like, you know, sample 8 by 8, I guess let me actually draw it for you. So if I actually do 8 by 8 samples, right? If I actually do 64 samples inside my pixel with the correct offset on the pixel, average those results together, that gives me a 64 shade, right, sample, right? Which is not great, but it's a lot better than not doing it. So that's one thing you could do. You could crank those up to 256 samples if you want to. Again, really getting very expensive for the graphics card, so you just don't want to do this, but then that would give you a full 256 shade sample, but only 16 in either direction, right? So that means you would still see a 16-step stare as the thing moves from one to the other, which is not as good, right? But it's probably the best we can do if we have to inject ourselves into somebody's pipeline, right? Now, how would we do this really well so that it's both basically free, almost, and perfect, right? How do we do this? Well, if we're in control of the pipeline, if we write this game, right, then it's really easy for us to solve this problem, because all we do is leave linear filtering turned on, because bilinear filtering does exactly what we want. It blends the two colors from the two neighboring texels The only problem is it doesn't blend them at the right ratio, right? What's linear filtering? What is it, right? Well, linear filtering is pretty simple. It's just computing some blend coefficient, right? And it's saying 1 minus the blend coefficient times color 0 plus the blend coefficient times color 1. This is the entire this is the entire thing, right? If this is my blend coefficient. Right? That's exactly what we want. Remember, if I was to take a huge number of samples, 1,000,000 samples, 1 billion samples inside my pixel, right? And then I averaged all the samples together, what do I know about that result? Well, all of the samples are coming from in between to some pixels on my texture map. If this is my texture map, this pixel maps to something in here that is only, because I remember this is pixel art, it's big, it's blocky, right? It's coming from 4 total samples. There's only 4 total texture places to sample from for any given pixel. A lot of times there might only be 2 or something, right? If it's like that pixel there or something, right? So I know that my entire thing comes down to 1 bilinear sample, and no matter how many samples I took, I'm always hitting one of these colors, right? So for bilinear, right, we're talking about 2 of these. It's U and V, right? So for bilinear, I've got U equals my horizontal coefficient, and V equals my vertical coefficient, right? And so all I need to know is that if I was going to apply bilinear sampling, right, which bilinear sampling is just saying, all right, I want to do linear sampling. I want to do it on 4 things at once. So here's my color 0, here's my color 1, here's my color 2, here's my color 3, right? I'm just going to blend between 2 of them first, and then blend between the result of those, right? How do I do that? Well, I say, okay, 1 minus U times C0 plus U times C1. That's the linear blend. It's blending smoothly as U goes from 0 to 1. It blends between 0, 0, and Z1 in a linear fashion, right? Just a regular, straightforward fade. I would do the same thing with C2 and C3. These are my 2 intermediate colors, right? So this is like essentially creating 2 intermediate blended colors. I'll call those B0 and B1, right? And then I make my bilinear filter by filtering those. So I say 1 minus V times B0 plus V times B1. And this is my final color. That's the pixel, right? Or I should say, it's the output of the blend sample. So it's the sample, right? That's the texture sample. This is bilinear filtering. If I multiply this out, we can see what happens, right? I've got an equation here that's actually written in terms of these other equations. Let's just fill it in. I've got 1 minus V times my B0, which is 1 minus U times C0 plus U times C1. Added to the same exact thing, right? 1 minus U. I should make sure that's, oops. Get my U's and V's confirmed, sorry. 1 minus V. I always draw these poorly, and you have to draw them well because they look the same if you don't. 1 minus V times 1 minus U C0 plus U C1 added to V times the same equation but with the other C's. 1 minus U C2 plus U C3. Okay? What can you see about this equation? Well, if I was to multiply it through, it's very clear that it becomes just 4 colors added with 4 weights. What are the weights? Just distributed property, just like boring high school math, right? It's actually junior high school math, really, right? I multiply this through, 1 minus V times 1 times U. That becomes my C0 coefficient. 1 minus V plus 1 minus V times U, C1, that's my C1 coefficient. V, 1 minus U times C2, that's my C2 coefficient. And then VU is my C3 coefficient, right? Right? These are all just constants. They're just values that are two scalars multiplied together. So really, I could just say, all right, I've got a blend value. It's equal to that times C0, plus another blend value, right? It's equal to that times C1, plus another blend value times C2. It's that one, right? And finally, a third blend value times C3. Okay? This is the final equation for a bilinear sample. That bilinear sample is computed by using this exact kind of math, the 1 minus v, 1 minus u, you know, that linear blend, on the graphics card by using the UV coordinates of the texture that you sample, right? When I actually go to sample from that texture, like that one I had, right? This was the texture we were talking about before. Oops, suddenly I had an extra row in there. Pretend that doesn't exist. When I go to sample from my texture, where do these blend coefficients come from? Well, wherever I'm going to sample, right, is given to me, and I probably should have, you know, I used UV here because that's how you normally write a bilinear blend. It's going to be a little confusing because you also have UV coordinates for your texture. I'm going to call those UV coordinates something a little bit different. So I'm going to say like the UV coordinates, which are something a little bit different, right? The UV coordinates, I'm going to call those something else for now, right? I'm going to call those like A comma B or something, right? So that's the coordinates into the texture that I'm sampling. Wherever I'm sampling, let's say it's right here in my texture, depending on how the texture sampling is going to compute those UV coordinates, I believe it usually does them for from texel centers, but I'd have to go back and you have to actually go back and look at the exact math every time because I always forget exactly how graphics cards choose to implement it. Graphics cards don't sample textures the way I would have sampled textures, so it's always a mental shift. Especially Mipmapping doesn't work the way I would have done it, so it's always I got to go back and remember, wait, how did they decide to do it in graphics cards again? And then go, ooh, I don't like that. But anyway, point being, it's going to have some reference where if you sampled at that reference point, you would get exactly 0 for U and V, right? So this point in the center of the texel, let's say, is exactly 0, 0 for the U and V in the above equations. What that means is 1 minus U is always 1, and U is always 0, right? What would happen to my equation in that case? Well, this is 0, so you don't get, I'm sorry, this is 1 because it's 1 times 1, right? This is 0 because there's a U in it, which is 0. This is 0 because there's a V in it, which is 0. And this is 0 because there's a V and a U in it, so it's 0. That means we would just have color 0. That's the center of the texel. It's when you're specifically sampling it directly. And even with bilinear filtering turned on, you get the exact result of just that texture color. It's going to be important later. Remember that, right? Anywhere else inside this rectangle sample, I'm going to actually have different values. Let's say it's right here, where it's 0.5, 0.5, right, would be the U and V. You can see how it does it. If I map into the texel grid and I say, how far am I from the closest floor, right, the closest texel I would floor to. So anywhere in this square of sampling, I go to the min value, the minimum integer value of sampling I could do to my texel, right? Where is that thing? And then how far away am I from it, right? So here would be 0.5, 0.5, because I'm halfway in both U and V to the next texel center, right? Well, then all of these values would get a value, and what value do they get? The same value. 0.5, 1 minus 0.5, 1 minus 0.5, that's 0.5 times 0.5. So that's 0.25, 0.25, 0.25, 0.25. It's the average of all the colors, right? See what I'm saying? So on and so forth. I know how the graphics card will do this, right? It will map the UV coordinates in exactly this way. It will take the floor, step 1, it'll take the place where it's at, it'll floor it to the closest texel. Step 2, find the offset, right? That's saying, okay, I floored to this 0, 0 here. How far away from it? 0.5, 0.5, right? So UV equals that offset. Step 3, compute the blend coefficients. And step 4, blend. Right? So I know that I can't control these two, but I can control these two. Because when I pass in my UV value, it's whatever I say it is. This is the world of programmable graphics hardware. That sampler is going to get exactly the UV coordinates that I tell it, right? So the only thing you have to do if you want perfect pixel sampling, smooth sub-pixel rendering on your pixel art games with no smearing, just perfect texel filtering, right? All you have to do is recognize the fact that you can precondition your UV coordinates in the pixel sampler. This is it. Please, for the love of God, if anyone at Unity ever watches this thing, add it to your engine. I play so many Unity 2D games that just hurt my eyes. Make this a checkbox. For the love of God, make it a checkbox. Please. I don't know how to beg you enough, whoever is out there, Unity devs, just add some proper sampling to your 2D stuff. I mean, how hard? It can't be that hard. There's so many. There's more 2D games shipped in Unity than 3D games, probably. Just please. But anyway. So, all you need to do is precondition your UV coordinates, right? Let's go back and just take it one dimension at a time, because we can actually do this on both dimensions separately. We don't need to take into account the 2D nature of it at all, right? So again, looking back at it in one dimensions, that's good. In one dimension, I guess I don't even have to do it in one dimension. I know that the linear filtering will basically say it's going to compute some t value, right? And that t value is going to be the floored offset in texture space, right? So I'm looking at something like this. Here's a 1D representation of just one dimension of my texture, right? So it's just one row of texels. In fact, let me just draw it that way to make it simple. One row of texels, you know, I've got some different things in here. Different colors, right? This is my pixel art. I know what's going to happen is whatever coordinate I pass in on the number line. Here's my one dimension, right? Whatever number I pass in on the number line, and I can use U's and V's now because I'll use T as the blend. So we'll say U is the incoming U coordinate. T will be the T will be the blend coefficient. So I'm going to pass in a U coordinate. That U coordinate is somewhere like this, right? That's the U coordinate, right? I know it's going to take the span between the two texels. It's going to figure out where this is, and it's going to produce a t value based on that. So it's going to floor and then produce the offset, and that's my t value. Then it's going to do 1 minus t times the pixel on this side, right? C0, plus t times the pixel on the other side, right? This is the blend I need it to do, but it's using the wrong t value. It's using that smearing t value, so I don't get good, for pixel art, it looks ugly. It looks like it's all fuzzy, right? And I don't want that. All I want is sub-pixel correction so that at the place where the pixel art actually goes from one block to another block, I get it nice and smoothly sampled as if I had really good anti-aliasing on, right? Okay, so how do I do that? Well, all I have to do is say, where does this pixel fall in texture space, right? Because remember, in my pixel shader now, I'm talking about rendering a pixel that lands somewhere in texture space. Most of the time, because this is pixel art, so it's bigger than the resolution of the screen most of the time, most of the time I'm a small span, like this, sampling only one pixel. So what I want to do is basically have effectively what amounts to an if in my shader, although it can also be done as non-if. But what I want to do is say if I'm in 1, we'll probably do it as like clamps and stuff is all I'm saying, but if the pixel is entirely contained, right? So the first step is if the pixel is entirely contained within 1 texel, right? Because I know that answer. If the pixel is entirely contained, then floor myself, right? Just do the floor myself. So in the pixel shader, I will adjust my U coordinate to land exactly at the pixel center. So in this case, I'll adjust it so it's exactly here, right? So I know, for example, if this thing was 256 pixels, texels, right? If I know my texture is 256 texels wide, let's say, then I know that I want to floor to exactly, stepping in by from 0 to 1 to 2, right? I want to do 2 times 1 over 256, right? Plus that 0.5 offset, you know what I'm saying? So it's actually, 2 plus 0.5 times 1 over 256, right? So I just get 2.5 over 256. That is the exact location that I want to be for sampling that second texel. Exactly. Even in linear blending mode, because I'm right in the center, right? So I'll get exactly the right result. So if the pixel is entirely contained, I do the exact flooring that the texture sampler is going to do anyway, so that when it does the floor, it gets the same answer and the offset's 0. That makes the linear go away. It gives me back entirely C0, and I'm done, right? So how would I do that? How would I make that happen, right? Well, it's pretty simple. I know what my incoming UV coordinates are, and I can pretty trivially produce this number from them knowing the width of the texture, which I always do, because it's actually just provided in modern samplers. You know what the width of the texture is, but even if you didn't, you could send it down as part of either the Vertex data or the constant store, so it's pretty easy to just get that information in even if you didn't have it readily available from the texture, but you do, right? So when we look at this and we say, all right, we need to do this first step of the process, we need to be able to do a route where we're actually going to clamp, sort of floor this sample to exactly what it is. All we have to do is produce these values. And I won't go over the most optimal way to do it because I have to sit here and actually work it through. But you can imagine just doing it the reverse way. The most simple way to do it is just to emulate exactly what the texture sample is going to do. I get a U value. I know my texture width. So let's say I have a W value, that's the width of my texture, and an H value, right? And maybe I'll be more specific about those. So I'll say we have a texture width. It's a little bit bad because I wanted T to be my blend. So maybe we'll do something a little bit. Can I change? Let's change this. I don't know. I need more values. I need more values. Well, I need more values here because I don't want to step on my own toes. So I want the texture width and height here. So I'm going to do it this way. WT height T for width and height of the texture. And we'll just call it that. So let's start. We come in here. We have a U coordinate. This is the actual U coordinate that comes in from the Vertex shader, right? And that's where we would be sampling. And we've got bilinear turned on. So if we just let that flow through and we sample, right? We're just going to get a smear. That's going to be ugly. So first step, multiply out by the width. Where are we, right? So the first thing we want to do is find out where we are in actual texel space. So it's basically like our X position in the texture, right? That's going to be U times that width, okay? So that goes from something that looks like just a random U coordinate, like, 0.0125, blah, 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 to something that we can actually use, like, oh, it's 2.7, right? So that's 2 pixels in and then 0.7 of the way to the next pixel, right? Okay, makes sense? And so then I can also, if I want to, I can think about this a little bit more broadly and say, well, that's where I'm actually sampling. But I really would like to know more specifically, right? I really would like to know the span of the sample, because this doesn't really tell me that. So what I'd like to do is know what the minimum and maximum values actually are for my sample. Remember, I want to know if I'm completely covered. So here and here, right? I've got those 2 points. I want to know how much of that span falls within the pixel. So just taking the center point, which is here, isn't that useful for me. I'd rather have the min-max, right? So what I need in addition is something that you actually get. You get texture gradients, which are basically like du dx and dv dx. You get these in the shaders, and what they say is, if I was to step 1 pixel, right? If I was to step 1 pixel forward or 1 pixel back, how much would my u value change? So really what I want to do is do something a little bit more broadly. What I want to do is make a u min value, right? U min is going to be stepping a half pixel backwards and a half pixel forwards, right? So what I want to do is say u plus, like, 0.5 du dx. Oh, sorry. I mean minus 0.5 du dx, right? And u max is going to be equal to u plus 0.5 du dx, right? And then I can do an x min x max. So my x min is going to be my u min times wt, and my x max is going to be my u max times wt. And this gives me the exact span. So it would say something like, oh, we are sampling from 2.5 to 2.9, right? That's where we're sampling. So now, if you actually wanted to implement it with an if statement, you just could. You'd say if, floor or round, doesn't matter which one you use here. If floor of x min equals floor of x max, then we want to set our u value to actually be the floor, right? And we'll talk about what that computation is. It's really simple right now that we have this. It's literally just take this value here, this uwt. All we really wanted to do is floor that value. So you would literally just do the floor of uwt divided by the texture width to map it back into texture coordinate space, right? Make sense? So if you actually wanted to do it with an if, you just could. So let's pretend we did that. Then all we need here to finish is just our else. We need to know what to do when we're not in the same texel, right? So now what we have is some kind of information about where we actually fall in the range of textures, right? So what we're going to have here is something that doesn't look like 2.5 to 2.9. Maybe it looks like something like 2.6 to 3.1, right? Something like that. Makes sense? And so, as opposed to sampling, only inside that one texel there, that second texel, we're sampling a little bit of the third texel. But you can see here, we're still mostly in this one. So we want to do the computation that figures out exactly how much of each of them we want to sample. Well, what is the actual value that we're looking for here? Well, you can kind of see how we would construct it. If we were to floor this thing to the correct 2.5 there, right? And I should add that we want to be, I kind of left out a step here. We actually want this thing to be looking at how it is arranged around the 0.5s. So we actually, when we're in here, I probably shouldn't have written it this way because we don't have a good way of flooring to 0.5. So what we want to do is do the adjustment that makes us actually be around the pixel centers anyway, right? So what we want to do is actually add in here probably this bias, right? That centers us around the texel centers, so we don't have to worry. We can actually just use floor. So we probably want it to look like this. And then what we're looking at here is not is what I was saying here was more accurate, right? When we're entirely inside 2 as our first thing, we're fine, right? And so when we're inside here, now we're looking at something that spans them. Make sense? Okay. So if we wanted to know what the difference is here, right? How much we should blend between these two values. Well, if you look at what we're getting for sampling, we can compute the exact coverage. How much is in one texel, how much is in the other. How do we do that? Well, take the max and floor it, right? So we can just say, whatever this value is here, this is our Umax value. Whatever our our Xmax value. Whatever our Xmax value is, if we take our Xmax value and floor it, right, that would give us our 3. We then know the amount that's in the other, the 3 texel is just going to be however far the max was away from that, right? So we would say the Xmax value minus that floor value, right? That's going to be equal to the 0.1 that we had. And then on the other side, we know the opposite is also true. The floor value minus the max value, minus the X min value, this value here, right? That's going to be equal to how much is in that one. And so that would be 0.4, right? We then know that if we set up the ratio between these two, we know how to blend between them. We want 0.1 of this one and 0.4 of that one, right? Makes sense? So in order to figure out where to sample this thing, we know that we just need to sample it at a 0.1 to 0.4 ratio, which we should be able to normalize out. So I'll crank the math here, but again, not so good with grinding math on stream. It's kind of tough to do. I'm not good at grinding math anyway, but point being, so we just need to know how we would normalize this out. And how would you do that? So if you have a 0.1, 0.4, and you want these things to sum to 1, right? I want to do a total blend. So I want these things to sum to 1. Again, Euclidean 1 norm. We've talked about it on Handmade Hero. Look it up. If we don't know what it is, look at norms on Handmade Hero. We can talk about it more. But what we know about the Euclidean 1 norm, if we want our blend coefficients to sum to 1, which we do, we need to normalize by the 1 norm. What do you do for that? Add up all the values and divide. Right? Very, very simple. Very much like the Euclidean 2 norm where you add up the squared values, square root and divide. This is the Euclidean 1 norm. It's for summing to 1 rather than having a length of 1 in space. So, again, just briefly touch on that. That's what the norms are. All right. So if we add these up, what we get is Xmax minus F plus, well, actually, I'm going to do that a little bit lower. Xmax minus F plus F minus X min. Now, do you see something interesting about this? Our F's cancel, right? And we just get X max minus X min, okay? So if I want to sum up these values, the F is just kind of sitting there, so it goes away, drops out of that part of the term. Now, I said I needed to divide to find out what I actually wanted my answer to be, right? So if I want to divide to get my t value, right, to get a value that smoothly blends between them, and remember, for a t value, this value is always going to be 1 minus whatever the other value is once I make them sum to 1. So I can kind of ignore it. I can just use one of them. Let's say it's f minus x min in this case. Then what I can say is, all right, f minus x min, and x max was the floor. That's going to give us an equation that has an x min and an x max in it. I don't really want to do that necessarily, so I think what I want to do is an equation with 2 x maxes. So I'm going to pick this one, which is actually the 1 minus value, but that's okay. So looking at this, if I said x max minus floor of x max, right? That's what I'm doing here. Normalized X max minus X min. Make sense? Oh, you know what? I've got an xmin in here anyway, though, and there's really no way I'm getting around that. So let's get rid of that. Let me pretend I never said that. Let's just do this one the way I wanted to originally. So I have f minus xmin over xmax minus xmin, right? And if we take a look at what happens here, this right here is just floor xmax. So what I've got is floor xmax minus xmin over xmax minus xmin. Very, very simple equation. That is the actual t-value we want to do for our blend, which means if we want the graphics card to do it, all we have to do is put it back into texture space in the correct place. Now, how would we do that? Well, we're going to add, right, back in our floor of xmax, and then we're going to do our divide. That means in order to put this back into texture space, and there's a couple ways I could have done it. I wonder if I should have done it instead by flooring xmin. I don't know. That's kind of an interesting question. I probably should have done it with floor xmin. Let's do that really quickly that way as well. Again, we've just got this diagram basically. You know what I'm saying? And what we're doing is we're saying, well, we've got a texture sample that's going to come in here somewhere. Let's say it comes in here, right? We know that this is the center of the texels. This is at like 0.5, so this might be like 1.5. This right here might be like 0.5. That would be like 2.5, right? We know we want to sample right here. This value right here is going to be where we would floor to, and we're not flooring exactly to 1.5 because we're shifting our pixel grid over just so floor will work. But that's basically all we're doing, right? If we floored to xmin, we floored to xmax before. If we floor to xmin, we can still do the same computation, right? We can still figure out how much is in each one of these pretty easily, I think. I don't think we would have too much trouble. At least I can't imagine why. Because you don't really even know which one you're crossing anyway. You're just trying to figure out how much is on one side and how much is on the other side of whatever boundary you're crossing, and you know that each one is in a different texel because otherwise you would have just not hit that branch of the if, right? So anyway, if I was to do it with floor xmin, so we're producing this value here, right? Then all I really want to know is how far is it from the floored xmin to here, right? Then from here to here, and then from here to here, right? I'm trying to figure out what these two spans right there look like. And again, one of the reasons it's a little bit better to floor to the xmax is I think that always gives you the midline, which is a little bit easier to do. But we always know that this is 0.5 away from this. So it's not really particularly difficult, I don't think, to work that math through either. That's my guess. So I don't know. As I'm looking at it, I guess it's not easy that way. So I'll just keep going with the way I was going. All right, so if this is what we have here, now what we want to do, since we have floor xmax minus xmin, xmax minus xmin, this is our blend coefficient. Remember, that just gives us a t value, so it's a value that goes from 0 to 1. What we want to do now is we've got this u value. We want to readjust our u value, right? Our sample value maybe was here or whatever, right? We want to adjust that so that the graphics card will do the correct bilinear blend that computes how much pixel coverage there was for this particular, for each side of the texel. The texel on this side and the texel on this side of our pixel boundary, which is like sampling there or something, right? So when we look at how we have to do that, what we want to do is first create the u value in expanded space, so the x coordinate that we would actually need. So our x sample, right, I'll just call that xs, right? What we want to do is say this is the t value. This offset here is basically telling us how much we want to sample away from our xmin, right? So this x sample position is going to be whatever our xmin was, which we know, I'm sorry, not our xmin. It's going to be however far off of the texture sample for our floored xmin, right? So our floored xmin here, we know we want to be that far forward from it, but since we already floored our xmax, we could also think of it as being how far backwards from that we want, right? So if we look at our floor xmax, which we've already computed, That's out here. We just want to say that floored X max value, we want to sample 1 minus this value behind it, right? So we just want to subtract 1 minus this expression here. Again, we only have to compute that floor X max once. Right? So we know this is the equation we actually want to compute for the location we're going to sample. We're taking the pixel center of the far texel, and we're moving backwards by the amount we want to force the graphics card to blend. What does that end up being? Who knows? This may be, there may be some sloppy math errors in here. But you would grind this through, maybe use a computer algebra system to help you. But we're going to want to multiply this out. In fact, let me just start by multiplying out 1 minus this value. That's going to be a minus distribute to the 1. Then a minus distribute to this will cause this to be a plus. Then we've got our floor X max minus X min over X max minus X min, right? This is the actual equation now as it stands. If I want to start combining terms here, I would multiply through by X max minus X min. So that would give me a floor X max times X max minus X min over, well, the whole thing is going to be over X max minus X min, right? Minus 1, same thing. I'm sorry, minus X max minus my win. Like so. And then plus the remainder of the equation. Floor X max minus X min. Okay? So what you can see here is we basically have this big distribution to do now. If we look at what the actual values come out to be, we've got a minus X min in here. So we've got 2 of those, right? If I start to group terms, right? So this is a minus 2 X min here. I've got a minus X max. This will distribute out. So basically, the floor X max, it's going to be floor X max times X max minus floor X max times X min minus X max plus floor X max minus 2 X max, right? I've probably already made so many math errors. This is one I would definitely want computer algebra for, but for what it's worth. So if you look at how this actually works out, these 2 X maxes also kind of coalesce, and so we get minus 2 X max in here and 2 X max with the floor X max. So if we grouped all those terms together, we would actually get, I believe, floor X max. Right, if you look at this, we've got 2 oh no, we don't. Never mind. That may be it. So that may be it for simplification that we can do there. That was a min, not a max. So that may be all we can do for simplification by multiplying out. I don't really know that we would want to necessarily do that. It doesn't look particularly good. I was just looking to see if there's any cancellation, because this is pretty simple to compute right here. It's like very, 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 it's a, you know, you compute the floor once, then you do a few minuses and 1 divide, right? So it's pretty straightforward. There's not a lot to it. This would be our X sample value. We would then add the 0.5 offset back in and divide by the texture width, and we'd be done, right? Make sense? Now, one of the things that may be true is this may now take care of our if for us as well. So if you look at what's going to happen, if X min and X max is 0, right? It would be nice if we could figure out a way to get that into a multiply, and we might actually be able to do that. I feel like we should dig in a little bit further here. Because if we did, then we would be able to just make that be a coefficient, which drops out to 0, right? So let's try and phrase this in terms of a differential in some way, right? Let's try to make this something that we just go ahead and add in a way that will give us some kind of a coefficient that we actually can use that's not going to be a 1 over, right, in this particular case. So how would I do that? Just trying to think. Because there should be a way to grind this math out, I would think, having never looked at this really before. I think there's a probably way that I could do this a little bit more straightforward, right? What I want to do here is basically say, is there a change of reference that I can do that just says how much is the offset that I actually need to go from my original U in order to get there? And if I was to assume that this was correct, then what I could do, I suppose, is say we know my original U, right, the original U value that I started with, is actually going to be a value we know. It's going to be it's going to be 0.5 times x max minus x min, right, plus x min. We know where it is effectively, right? So if we were to phrase this as we want the difference between this point and this point, right? So we actually want our sample value to be that, right? I want floor x max minus 1 plus floor x max. Is it minus x min or plus x min probably? What was it? Floor x max minus x min over x max minus x min, right? So the total with x max minus x min also is just 1 pixel size in texture space. So we kind of already know what that is as well. It's a pretty straightforward value. So, you know, now that I think about it, we don't really need to ever worry about that because it's a known value. X max minus x min in this case is just 1 pixel in texture space and is actually just the du value, right? So dx du, I'm sorry, du dx in the pixel shader would actually map directly to this. So this, because that is 1 pixels wide, because we know that max and min are 1 pixel wide. So really, this doesn't exist. This is just a multiplication, a divide by the du value that we get in the pixel shader, right? So that's actually quite simple. We know that floor x max minus 1 in this case also, so that we actually also know. That we actually also know, right? Because x max minus floor x max minus 1 is just moving us 1 texel backwards, right? So that's always constant. Floor x max we got in both places, and then the x min. So really, it's just this part. Really, it's just that part. And if we got that part, it's just a C move. So really, you know, I think there's probably a subtler way to do this. And maybe tomorrow what we should do is dedicate a stream to just working out all the math exactly. But basically all you're doing is just adjusting this value, right? You can just probably C move that value because this entire equation is just all known stuff. And so what you could do is just say, look, set your x min to either exactly be, to either just be the offset of because your floor x max, right, is going to be the value you want. So actually you can just set this to be 0 in that if case. So our if is just x min, right, equals the actual x-min we computed. That's what we do. Yeah, it's pretty simple, actually. Where was that value? Too much math. So this value here, all we actually have to do is say, set this value to 0 if this is true, right? So it's just a C move, almost free, right? So all we do is say, if the floor of xmin equals the floor of xmax, xmin equals 0, otherwise xmin stays the same, then we compute this equation, and we're done. Right? Then we get exact sampling in all cases. We do that for both our u and our v. Again, it's a few multiplies and a div. The div's not great, but it could be approximate. I don't know if we can get rid of it. The good news is it's constant across the pixel shader for a particular texture. So actually, we could set it. This could be set in the constant store, and we wouldn't actually have to do a divide. You could just do a multiply, right? So again, pretty simple stuff. If we actually work this out in the pixel shader, it's a handful of instructions that we would issue, and it would solve all of the sampling problems. Now, there's a little more you would want to do here if you're going to mipmap, but we're out of time for today. And in the case of Children of Morta, most of what I'm seeing is not mipmap errors. It's this. So this needs to be fixed. And again, it's in Unity. I guess it's Unity's problem. But before I leave, I want to see on the chat. It looks like we can set minus force GL core inside as a launch parameter potentially in Children of Morta. And if that's true, we may be able to actually edit the shader. So before we end for the day, let's just try and see if we can do that. Oops. Okay. So what I'm going to do now is see if I can add that as a launch parameter. I don't know that it would go here. I may have to go into Steam and set it. So I may have to do, I don't know that this will work. So we'll try it, but we may have to just go into Steam and set additional parameters there. We'll give it a shot here and just see what happens. Looks like that did work because Initialized Graphics Engine said it failed. So that suggests to me that it did work, but it didn't actually help. Maybe GL Core isn't supported. So I don't know. It looks like that just may not have gotten shipped. It may be because there's no source code for the shaders, so it may be that they just precompiled them and they only exist precompiled. You know what I mean? But yeah. So sadly, not much we can really do here. I wish we could edit those shader parameters, but it doesn't look like we can. If I pop back to nSight here, I'll do one more thing before we stop. Oops, I'm going to load up that Children of Morta. I'm going to go ahead and try and launch. We'll have to go through this little dance here real quick. There's that Steam thunk. I wonder if there's a Unity parameter to disable Steam, because that would also help us. So basically, I'm just going to go ahead and try and capture a frame and then save it out. Alright, and so if we take a look here, all I want to do is get another one of those frame captures in the mix. And so I'm going to pop back over here. I'm going to try to do the attach, like so. And it looks like it's okay. I'm going to capture for live analysis. And let it kind of fail a bit, but it still does get us a frame we can use. At least it seemed like it does. I'm then going to go ahead and just save out export C++ capture. I don't know what this will actually do and whether that will let us actually do anything with it, but we'll try. And then I'm going to go ahead and exit out of nSight, and we'll just see. I'm going to go ahead and also close Children of Morta as well, or try to anyway. Oops. I don't seem to be able to. Let's try it through here. All right. So what I would like to do now is just take a quick look at what that actually dumped out, because I don't know to what extent that gives us anything we could use. But I just wanted to see what that actually puts in my directory here. So here is some C code. It's got a big ol' hunk of binary data. It looks like unfortunately, I want to say I don't think it actually gave us something we could really use because it doesn't have the shaders in here, I don't think. Yeah, so you can kind of see, like, I think what they do is they just bundle all the shaders up into this data bin file here. So they're probably in there along with all of the actual data. We could still go ahead and try to intercept what that shader was and then replace it with a different one when it gets submitted. The problem with that is that's going to take a while for us to hunt down. So I'm not going to do that today, but we could try doing it tomorrow, right? And see how we go. All right, I'm going to go ahead and quickly go to Q&A, and we'll just... Someone says, here's a good side-by-side sample of the artifacts you're talking about at Shader Toy. Okay, that would be nice. Yeah. Those are exactly the ones I'm talking about. You can see all that shimmering? There's no need for any of that. It can just look perfectly smooth, and you would never know that it was using filtering at all. You wouldn't see those objectionable artifacts, those shimmery artifacts as it moves around. And you know what? While we've got this here, I can, I probably should have, in fact, maybe this is what we'll do tomorrow. If we just do it here, we can fix it in here instead. And then hopefully maybe someone at Unity will add it or something. It just sucks to play so many games with this artifact for no reason. It's free once you work out the rest of the math. It's even simpler than what I did, because I just did the first path to show you how to work out the math, the basic idea behind it. But if you actually sit down and have a whole day that you spend looking at this, you could probably get it down to something incredibly small, right? Just like really, really, really small, if that makes sense. All right, so what is this actually doing, though? This is not. This is doing something slightly different, because this is not the same as turning off the bilinear filtering, which so I'm a little confused. This looks like they're actually doing the update, but this looks shimmery to me. So I'm super confused. Oh, I see. It's divided. Oh, yeah, okay. So that's the good version. Okay, perfect. Never mind. Yeah, you're right. So how did they do this in Shader Toy? I don't know Shader Toy very well. How are they making it so that it has like two separate shaders, one for each side of the thing? But yeah, perfect. So I guess I don't know why got too carried away. I was looking at it, I was like, it looks like they're doing the fix up. So here you can see the difference. I mean, it's just not, there's no reason you would ever want to see this. It's not an aesthetic choice, it just looks wrong. You always want the one on the right side. I mean, that's what you want. And the right one is doing the fix-up I was talking about. It's not quite doing it, I don't think, the same way I would do it after working it through, but it's doing it, right? And so this is just always wrong. And this is what happens. Like, this is what Children of Morta or generally Unity games do. And you always want this one because it's free. It's really no slower. It's like slightly, there's a little more arithmetic in the shader, but very, very little. And especially you saw that Children of Morta shader. It was huge. So we're talking about a little tiny, a few additions here, right? So again, I don't really know how to use Shader Toy, so I'm not sure I understand how to have two-sided screen do other stuff. I guess what they're doing here probably is just looking at which side of the screen you're on and then picking one of those. So there's probably a selector in here somewhere. So yeah, okay, so it's right here. So if I.x greater than center x, that's what's giving us that dividing line, right? So if I wanted the whole image to be right, I could do it the other way around, right? This is what puts in the black bar in the center. I could make it larger. Right? So now you can more clearly see it on the stream. So the if statement's doing that. And you don't need, so Shader Toy isn't doing a thing there. That was just someone doing it for illustration purposes. So if we look, we're talking only about these lines of code here that happen inside the if. These are prepping it, and then these are actually doing the fractional offset there. This is just adding the black bar. So if we got rid of it, it would still be exactly the same image. It's just now you can't see. Oh, oops. Why can't I delete that line? That should only be the black bar, right? What's the problem? Oh, because the else. So looking at this, now we have just the left side is still wrong. I can remove this, right? And now we just have the proper way that, you know, a Unity game would look if they had these, if they had the correct shaders. And that just looks so much nicer, right? So again, like looking at this, you can see how simple this is. And it's, you can see the floor and you can see the clamping there going on. So this is worked out. It looks like this is worked out pretty clean. So you can see if you do grind that math through, you get a much better result than what we stopped on, because we still had the if. They're doing the if is in this clamp right here. So you can just get it into a clamp like I had sort of whimsically stated. So again, very, very straightforward. If we look in and see what's going on here, this stuff is just because they need, you know, it's shader choice. They have to build everything in here. So all of the motion and zooming and stuff is sort of baked into these lines of code. So we don't really care about those. This is where you would, this is what you'd actually be doing inside your shader. And actually this part right here is just preparing the texture coordinates anyway. So really we're talking mostly about this, right? So in here you can see the first step of the process is we're taking wherever we wanted to sample inside our texture, and we're flooring the value. Again, if you look at this, these are coming in pixel coordinates, so you would have to first multiply by the size of your texture, because that's baked in here. You can see in here this stuff is baking in that pixel size. So that's the size. That's the size of the pixels in your texture, how big you wanted them to be, right? So that's how they baked that in there. So in here, what we want to do is say, all right, we've got the UV coordinates. We're flooring where we're looking up, and we're adding that 0.5. Remember, I said we wanted to shift everything over so that it would floor down properly. We're then taking the UV coordinates, and we're doing, again, that sampling backwards from the max here. So we're doing a minus of the clamp. That's the fractional value of J is the X min minus X max. I'm sorry, the floor X minus X to get that fractional value. The scale value here is probably just how big you wanted things to be. Yeah, and then we're just going to sample normally, right? So really everything they're using for sampling is wrapped up in here. This isn't probably how you would write it. This is assuming some stuff about the way you're sampling the textures that isn't as generic as you would want, I don't think. Because you notice they didn't put rotation in here, and I think this is kind of, well, I guess you could do it this way with rotation still. But we should probably write a shader toy that does the correct thing with just a regular texture sampling rather than moving it in like this. But either way, right? Children of Morta looks like a fairly ambitious game. Why do you think they didn't bother to implement proper per pixel rendering? Again, because that's not their job. The reason they license Unity is it's supposed to be the graphics engine, right? So they probably don't have a bunch of expert graphics programmers on the Children of Morta team. That's, if they did, they would have written their own engine potentially, right? So I kind of feel like that's the problem. It's not really Children of Morta's fault. It's Unity's fault. How did you learn about this artifact? How did you figure out the cause? Well, it's not really a new artifact. It's the same artifact we always have, which is subpixel rendering. In the old days, games didn't have the horsepower to do subpixel rendering. That's why you go look at really early games, and they're very crispy. As thing moves around, you get all those artifacts. But as we've gotten more understanding of how graphics works, and we have more horsepower, we generally think about things from the perspective of subpixel rendering. So this is just basic subpixel rendering. That's all it is. Oh wow, this shader toy is by D7 Samurai. Thank you, D7. Thanks for writing it. Someone posted a link before saying Unity has a pixel perfect 2D package. So what is that? So I can't tell if this actually helps though. This sounds more like it just snaps sprites to the nearest pixel coordinate, which is would not help you, right? Because you're trying to get smooth motion of the sprites, and you're not going to get that, right? So I don't know. I don't use Unity, so I couldn't tell you, but it's not clear from the explanation here whether this would actually do what we're talking about or not. And you know what? This is totally wrong. Yeah. So this is nothing like what we're talking about. So and this is ridiculous. I don't know why you'd ever do this. That doesn't even make any sense. So no, that's not relevant at all. Is any extra work required for oblique viewing? No, because this is all in texture space, right? So it has nothing to do with whether it's rotated or scaled or moved or anything. It's just how you sample a texture if you want the texture to be a step function instead of a linear function, right? But everything else just works. So all you're trying to do is do the step function, and off you go, right? How is pow function implemented? How would you go about implementing an efficient power function? All of those tend to just be basically fit. You always just fit some kind of like a Taylor series or pow function. Modern numerical programming is probably Taylor series is like old news. So you just fit equations to the power function, and you evaluate those equations iteratively till you get the desired bit precision. That's how all of that stuff works. That's how sine and cosine works. you know, you could look. Isn't it called sleeve? You can just look at a generic, you know, math library somewhere out there that's set up for this sort of thing. And you can go ahead and look at sort of roughly the way they're doing it. It's not very, it doesn't really explain much how it's actually working. So I do apologize for that. But here you go. If you look at how these things tend to be implemented, you can see that generally speaking, they've got some fit function here. So for example, here, this is the thing that actually does the work. So every numerical function, because remember, these libraries have to implement proper handling of these functions. They can't just poop it out. So they've got to look for things like infinities and nans and stuff. So basically what you'll have is you'll see something like this. This is the preconditioning. Then it will call something that is basically like a series of its basic functions. So in this case, it uses an abs, a log, a mul, and an exp to implement it. And here is an example of one of the implementations. So here is an xpk2f. And what you can see is it's just a series expansion. So somebody fit some series to this thing, and they basically just do a bunch of like fads or fmads or whatever you're going to do, multiplications. That's all anyone ever does that I've ever seen. So basically the process is you take the function you're trying to simulate, like pow or anything else, you figure out what range you care about it. You can put in a bunch of things to try and like cabin the range and precondition the number and handle infinities if you want that stuff. But if you're just using something where you know your inputs pretty intimately, you then fit that range to a function somehow, right? And sometimes you have to do that by breaking it into multiple steps, like multiple functions. Sometimes you can just do it directly. Then you compute that approximated function, and that's your result. And that's it. You can see here, there's typically stuff where you do use the exponent and the mantissa separately. That's a very common technique as well, because sometimes you can compute stuff on just the mantissa and then you don't have to worry about problems that have to do with where the exponent is and so on. So yeah, there's a lot of stuff like that. But that's all anyone ever does. And sleeve, I think, is I doubt it's particularly great or anything, but it's a pretty easy place to go. I think it's pretty open licensed. So basically, you just have to provide a slight notice that you used it. Is it, right? So you can cut and paste code from here and go nuts if you want to. So for sine or for cosine and sine, yeah, at some point I'd like to replace them. I just haven't gotten around to it yet. The problem with sine and cosine or pow or any of those things is questions about like, should we use a table lookup or should we do whatever? I have no idea. I don't spend a lot of time working on these sorts of numerical replacement sort of stuff. Possibly, right? I have like a hair in my face, probably Molly hair. So I really just don't know off the top of my head whether it's better or worse to use tables in the case of sine or cosine. What I will say is that oftentimes table driving an algorithm in this day and age is oftentimes not what you want. Not because there's some really bad thing about looking up stuff in a table, because if it's a small table and you're doing a lot of it, the cache probably has your back, you know? So small tables are very fast. The problem is you cannot do wide operations if you are using a table lookup, right? Because up until AVX 512, which is barely in any processors right now, you cannot do 4-wide table lookups. So what happens is if you actually try to table drive something, if you're trying to do 4 or 8-wide SIMD, tables become extraordinarily expensive because all of the elements have to be extracted from their lanes. You then have to do all the lookups, and then you do 4 separate loads and a packs to get them back into lanes that can then be used. So table driving is pretty rough these days. And, the hope, I think, and I mean, I guess I don't know, I can't speak for everybody, but the hope would be that someday when AVX 512 maybe is more prevalent, that penalty would go away. So if you have lane-based gather, then all of a sudden there wouldn't be a penalty anymore for table driving. And so, you know what I'm saying? So I feel like table driving at the moment is actually very difficult to do and make it run fast if you have to be wide, right? So I doubt we would do our sine and cosine with a table because we probably want to be able to do 4 at a time. That's just my feeling on it. So most of these math functions, I don't really like table driving them for only that reason. So if you can get away with not table driving it in this day and age, it's usually a benefit. Not for the reason people say, because a lot of people say don't table drive things because the memory cost is high. It's probably not. That's probably a lie. What's not a lie is that if you have to be wide, you're in trouble. Long Boolean says, is there ever a reason not to compute your pixels this way? Is this a 2D only thing? So you only want to do this if the original function was supposed to be a bunch of little squares, right? If the original function is supposed to be samples of a continuous image, then bilinear filtering is actually more correct as an upsampler. So actually the default bilinear sampling is what you want most of the time, right? But when you're dealing with pixel art, it's this unique case where the art itself is supposed to be made up of tiny little squares. And at that point, the sampling you want is very different than bilinear filtering. It seems that this artifact is quite well known, at least in your circle. Is there a name for it? I don't have a name for it. I don't know if there is a name for it. Let's make up a name for it. Let's call it... So since it's like all Unity games seem to have this artifact all the time, I'm going to call it the Unity artifact or Unifact. So we'll call this Unifact. This is a Unifact bug. Actually, maybe it shouldn't be because you're going to say this something artifact. So maybe it should be the Unity pixel art artifact or UPart artifact. Or I guess we would put the artifact on there, Unipixel art. So it'd be the Unipix artifact. Would that be right? So that's going to be the name. We're going to say that something looks Unipixy if it's kind of like doing that shimmering. Gigasite Media. The shader can only address artifacting within the texture, but cannot address subpixel occlusion artifacting, i.e. the shimmer is still present on exterior edge pixels. That is not true. It actually addresses it everywhere. So what happens is when you create your when you create your textures, and you saw us do this on Handmade Hero, when you create your textures, you leave a 1 pixel wide border around the texture that is completely blank. So it's alpha 0 everywhere. Then what happens is when you are sampling there, you get the correct alpha coverage value out from your sample, and there is no edge shimmering. So it is 100% correct everywhere, even on border pixels. Brian is asking, I was surprised to see how much latency was on division. Square root seems to have a similar latency, but reciprocal square root is as quick as multiply with just half the throughput. Why is reciprocal square root much faster than regular square root? The answer is because they're at different levels of precision. Just give you a little bit more information about that. So here is square root, and what you can see here is there's no qualifications in the statement here. So when Intel says they compute the square root of packed single precision 32-bit floating point elements in A, what they mean is they're actually computing the whole square root. So the mantissa is accurate out to like the last bit, possibly even with a additional bit of rounding precision built in there. So it's a pretty precise answer as far as can be ascertained. So if we look at reciprocal square root, what you can see is there's a very specific disclaimer. You can see here that actually it doesn't guarantee that it's producing an accurate result even as far as the 13th bit of the mantissa. Now there's 24 bits in a mantissa, so it's actually a significant number of the trailing bits of the value are wrong or possibly wrong. And so, you know, you can be faster if you're less accurate, and that's exactly what they've done here. They're giving you a really fast, basically a really fast approximate reciprocal square root, not an exact value, and hence it takes less time because there's probably in the actual thing that produces the actual square root, there's probably a bunch of stuff in there that's doing like refining, like it's taking multiple steps to refine the value or something, right? So this is like the minimum quick and dirty version of computing a square root, and specifically 1 over a square root, whereas the square root function's actually doing the whole square root all the way out till you run out of bits. Is there a less precise version of square root then? Yes, it's called r-squirt. The reason that they chose this breakdown is because typically speaking, if you're looking for fast and dirty, oftentimes the thing you're going to do with the square root immediately after you take it is take its reciprocal. So that's why it computes the reciprocal of the square root instead of the square root, because if you're looking for quick and dirty, reciprocal square root is actually probably what you want because you're probably normalizing something using the Euclidean 2 norm. Right? Could you do something similar inspection with some UE4 game and end the engine war for good? I don't know if there is an engine war. I mean, people get there's very different reasons why you would use Unity or Unreal or something, right? Unity should just fix this problem. I don't think they should just do the sampling properly. I feel like they should be able to put in something that can do that. There's a lot of graphics programmers at Unity. I don't know why they haven't fixed that. So the artifacting is still present here is because there's no border pixel. What artifacting are you talking about? I don't see any artifacting here. So what artifact are you talking about, Gigasite Media? There is one other place you can get edge artifacting, by the way, but it's not really on edges per se. It's on neighboring pixels with a high difference between them. And that's if you have gamma or perceptual gamma problems with the blend. So technically, you need to be gamma aware when you're actually doing this work if you really want it to be correct. But, you know, I'm not seeing any artifacts in this one right now. Maybe you can perceive a little bit of a little tiny blur on the edge once in a while, but I can't really barely see it at all. But what I would say is, yeah, like you do have to be careful about gamma at the edges when you're doing your all of your work, and this shader toy isn't. So it's possible that even that bit would be fixed, but that is not an edge pixels. That has nothing to do with edge pixels. The only reason it looks like it's on edge pixels is because the edge pixels are black and the background is white. So it's the highest difference between pixel values, which means it's where you will see errors in linearity show up the most because it's the biggest jump, right? Does that help? And so that's really where you're getting any visual shimmer there. I think it's just going to be in gamma because you've got that nonlinear ramp, and you've got to correctly account for that ramp. So the other thing too is this isn't implementing Mipmapping. So if we go down below 1 pixel, we would have a problem here. And Mipmapping pixel art is kind of a separate issue because then you have to actually think about how you want to downsample your things as well, which is kind of a whole nother ball of wax. But so yeah, any shimmering you see at this point is almost certainly either just gamma, or at some point when you get 1-to-1, you're going to have a little bit of limitation just because monitors are a limited resolution, right? So typically a pixel art game wants to be at least at 2-to-1 because, you know, it's pixel art, it's supposed to be big pixels. So generally you don't really want to go you know, all the way down, but yeah. All right, I'm gonna wrap it up. Thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you. As always, we weren't really coding today. We were just taking a look at what we could see if there's a way to replace the shaders in Children of Morta, because we were going to try and hack one in that correctly did the pixel sampling, but unfortunately we weren't really able to do that. So maybe tomorrow, I don't know, we'll see how we're feeling. Maybe tomorrow we'll just write our own. We could do it inside Handmade Hero pretty easily, right? Or maybe we'll just go back to working on our lighting system. Either way, not sure what we'll do, but I want to take a look at that because I think it would be pretty cool if we could have hacked in the shader. Normally, you can sort of intercept the shaders and replace them. In this case, we couldn't really do it. There might be a way of doing it by using some kind of driver extension where we, you know, because you could imagine us intercepting the shaders as they go down and just like replace that shader with our own shader. And that would, people do mods like that all the time. There's like, drivers you can install like that would do that for you. So unfortunately we weren't able to do that, but I don't know, maybe the Children of Morta team would let us just replace shaders for them. I don't know if you're allowed to do that in Unity. Probably you are. But we could work out what the correct thing to add to the shaders would be in that case, and we could have a Unity game that actually looked correct. That would be kind of cool. But really, the best possible outcome would be if the Unity team just add a mode for this. It's so simple. Yeah, I don't know. And yeah, if anyone on the stream knows how to unpack stuff, I don't work with Unity, but if anyone knows how to unpack it and get us into a part where we could actually update those shaders, I would give it a shot. Anyway, that's it for today. I'll be back here tomorrow. We'll probably just do some regular programming. I don't know how much more time I want to spend like trying to fix other people's shaders. But I probably will play some more Children of Morta pretty soon. Yeah, maybe we'll play some right now. I don't know. I'm going to go ahead and turn off the recording either way.